Hello and welcome. My name is Mark Alexa, and today I will be showing you how to protect your network against DHCP attacks. Specifically, I will show you how to configure a DHCP snooping on your Cisco switch, which blocks any DHCP attack. DHCP poisoning is a type of DHCP attack where rogue DHCP server pretends to be a legitimate DHCP server for the network. DHCP poisoning is taking advantage of DHCP IP address assignment, where the client or end host requests an IP address from the DHCP server on a network, and the DHCP server responds back to the request with an offering of an IP address. However, if the rogue DHCP server responds first, in that case what happens is that the client gets an IP address with a default gateway address, and in that very moment the rogue DHCP server becomes the default gateway. And what happens is that all the traffic, all the communication that passes through the DHCP gateway, the rogue one, will be exposed to the attacker, and the attacker then can monitor all the traffic, the confidential information, the communication between the members of staff. He can basically see all the traffic unencrypted. We can't have that. Okay, without further ado, let's get started. So we've got an example topology here with three laptops or end hosts. We've got two Cisco switches and two Cisco routers. Each one operates or acts as a DHCP server. One is legitimate and the other one is the rogue one, is the attacker's DHCP server. First, what we need to do is determine which interface the legitimate DHCP server is connected on. In a modern network, it's not always obvious, but thanks to CDP or Cisco Discovery Protocol, we can easily determine just that. So we will log into there. We'll log into switch 1, and from the privilege exec mode, we will run show CDP neighbor, and I can see the router 1, which is the legitimate DHCP server, is connected on fast internet 01. So in order to actually make changes or any configurations on Cisco devices, we need to enter the global configuration mode with configure terminal. We are in, and in order to actually enable this DHCP snooping on a Cisco switch, it needs to be enabled globally with IP DHCP snooping. And then it's not enough. We need to also execute DHCP snooping VLAN 1. It can be any VLAN, but it needs to be the one that actually is used on the Cisco switch. In our case, it's the default VLAN 1, so hence we are using the IP DHCP snooping VLAN 1. Then what we need to do is we need to run no IP DHCP snooping information option. The DHCP snooping automatically drops all traffic or all packets coming from client with the option 82 in it. DHCP snooping doesn't care if the device is acting as a DHCP relay agent or not. It's running DHCP service, so it will automatically drop it. So that's why we need to run this command to allow all this traffic to pass through. So with a DHCP snooping information option disabled, now what we can do, we can just go to the interface F01, and we can configure it as a trusted interface because it's facing the legitimate DHCP server. So we do DHCP snooping trust. That's it. That's it for switch 1. Now we pretty much do the same thing with the switch 2. Okay, enable. Again, we can just verify which interface the switch 1 is actually connected on. It will be probably fast internet 01 as well, but this time it's actually not this time it's not facing the legitimate DHCP server, but it's facing the switch, which is which is still trusted interface, because we are not expecting any invalid or malicious traffic on that interface. Show CDP neighbor, and yes, it's still fast Ethernet 01. That's fine. So configure, if I can spell right, configure terminal. And before I go and enter that interface, I will just enable the DHCP snooping globally. IP DHCP snooping, and then I will just hit an arrow up and VLAN 1, because I want it to be enabled for the VLAN, for the default VLAN 1. Now again, no IP DHCP snooping information option. That's done. And now interface F01 IP DHCP snooping trust. So that's it for now. Now let's head over to one of those computers and let's just verify that those laptops can request an IP address from the legitimate DHCP server, just to verify that actually everything is working so far. Okay, so config fast Ethernet, and I can see, I don't know, I'm not sure if you can see it, but it's very faint. It's very, yeah, it's very faint, but you can see 10.0.0.13. That's fine. Let's check over here. Fast Internet 0, yes, has been assigned, and the third laptop default gateway has been assigned, and 10.0.0.12, yeah. So all computers has been assigned with the correct IP address from the correct DHCP pool. Now, what I can do, what I will do, and I think this is the most interesting part of this video, I will simulate that the ROG DHCP server responds to the client's request message first before the legitimate does. The only way I can really simulate it here is that I will just shut down the fast Internet 01 interface. So let's do it. Okay, so interface F01 shut down. Yep, so it's down. And I can just, yeah, the red triangles indicate that the interface or the connection has been disabled. And now I will plug in the ROG DHCP server. Okay, we just need to wait about 30 seconds for the spanning tree to converge. Okay, so now what we can do, let's head over to one of those laptops and request a new IP address, and it shouldn't work. Okay, so command prompt ipconfig renew. And yes, we can see DHCP request failed. We can try the similar thing on. As you can see, those links, they're actually flashing or blinking, if you will. It's actually flashing because those laptops, they're actually trying to request a new IP address, but it keeps failing. Let's try on this one. ipconfig renew. And I can see it keeps trying to get the IP address, and the DHCP request failed. So this is the proof that the DHCP snooping is actually working and is in effect. So whoever is using the ROG DHCP server, the attacker, he can do pretty much nothing, because DHCP server, DHCP snooping is actually blocking all those attempts. That's exactly what we want. So now let me just re-enable the interface again. I can just cancel out this connection, and I can re-enable the interface. No, shut down. Okay, it will take probably it will take just a few seconds for the network to converge again, for the spanning tree to finish all those stages. In the meantime, I can perhaps just try to give it static like this. Static. Okay, so now I can see the network is converged. The spanning tree has finished, and I will just request a new request a new IP address from the DHCP pool. And it is there, 10.0.013. That's fine. The other one, let's do it. Fast Internet 0, and yes, we can see 10.0.011. Yep, and I can just double check. Yeah, 10.0.0 is the default gateway. That's the legitimate DHCP server's default IP address, or default gateway. Yep, that's exactly what we want it. Everything has been successful. I will just ping the default gateway just to check connectivity. 10.0.01. Yep, pings are coming through, and I can just check if I can ping the other laptop. There should be no issue with it at all. So this one is 10.0.012. So let's ping it. That's not what I wanted. Ping 10.0.012. And yes, pings are coming through. So we've got full connectivity. The attacker has attempted to exploit our network unsuccessfully, and yeah, that's how DHCP snooping works, how it's being enabled. Don't forget to run the no IP DHCP snooping information option, because it can trip people up. And yeah, I just want to thank you for watching this tutorial, and I hope you enjoyed and you learned something here, learned something useful. And yeah, just stay tuned and have a nice day. Bye.